In this section of the PPST, we will look at properties of whole number operations. And our operations are addition, subtraction, multiplication, and division. Remember again that our whole numbers is a set of numbers that include 0, and our counting numbers are our positive numbers 1, 2, 3, 4, and so on. We are going to look at 3 properties of whole number addition. Those are the commutative property, associative property, and the identity or the additive identity. The commutative property is just like the word commute, which means that order does not matter when we add two whole numbers. For example, 5 plus 3 would give us the same result as 3 plus 5, as both result in 8. In general, we can say if a and b are two whole numbers, then a plus b is the same as b plus a. The associative property extends this for 3 or more add-ins. Therefore, if we want to add 5, 3, and 7, we could first add 5 and 3, which would make 8, and then add 7, which would give 15. This would be the same as if we took 3 plus 7 to give 10, and then add 5 more. Notice adding 7 and 3 to make 10 was more compatible than 5 plus 3. So again, order does not matter in which I add. We will look at the additive identity, which is the whole number 0. And 0 is an identity element because if we add it to any whole number, we get that whole number back or identical to what we started with. Therefore, 5 plus 0 gives us the same as 0 plus 5, which is 5. Notice that the commutative property has to hold in order for a set to have an additive identity. Therefore, we might ask ourselves, do these properties hold for subtraction? For example, does a commutative property hold for whole number subtraction? The answer, well, let's see. If we took 5 minus 2, we would get 3. Is that the same as taking 2 minus 5? No, we would get negative 3. Therefore, the commutative property does not hold for subtraction. Likewise, subtraction does not have an identity, although we know that 5 minus 0 results back in 5, we'd have to have the commutative property for that additive identity, and 0 minus 5 gives us negative 5, so there is no subtractive identity. There are 4 properties of whole number multiplication, 2 of which are very similar. We have the commutative property of multiplication, which says order does not matter and when I multiply two whole numbers. Therefore, 5 times 3 is the same as 3 times 5, since both are 15. In general, we can say a times b is the same as b times a. We also have the associative property that says that if I was going to multiply 3 or more numbers, order does not matter. For example, if I want to find the product of 5 times 3 times 7, I could first find 5 times 3, which is 15, and then multiply it by 7 to get my answer. Or I could take 3 times 7 first to get 21, and 21 times 5 would also result in that answer of 105. We have the multiplicative identity, which is the whole number 1. And again, that multiplicative identity says that I would take 5 times 1 would be the same as 1 times 5, and I would get identical to what I started with, or 5 back. Finally, we have the distributive property of multiplication over addition. If I want to take 5 times a quantity of 3 plus 7, I could first add 3 plus 7 to get 10, then multiply it by 5 to get 50, or I can use a distributive property to distribute that multiplication through addition. Therefore, I'd get 5 times 3, which is 15, plus 5 times 7, which is 35, giving us 50 again. We might ask ourselves, do these properties hold for whole number division? And again, the answer is no. We know that 10 divided by 2 is 5, but 2 divided by 10 is 1/5, which are not equal. We also know that the distributive property would not hold.